All right, strap yourselves in because today we're taking a deep dive into a pretty mind-blowing area of astronomy, the Tychos model of the solar system.
Oh, that's a fun one.
While you're at it, make sure you hit that like and subscribe button
Yes.
to keep up with future deep dives.
Absolutely.
Because things are about to get cosmic.
It's going to be a wild ride.
So.
So the Tychos model, what's really cool about it is that it really challenges the way we usually think about our place in the universe, right?
Okay.
It takes all these familiar concepts like planets and moons and just throws them into a cosmic blender, creates a picture that's both strange and surprisingly elegant.
All right, I'm intrigued already, but
Good.
before we get lost in the cosmic weeds here,
Right.
let's set the stage.
Okay.
Most of us learned about the heliocentric model in school.
Right, the class.
Sun at the center, planets doing their orbital dance around it.
Right, the one we all know and love.
But there was another contender back in the day, right? The geocentric model.
Oh, yeah.
With Earth as the queen bee at the center of everything.
Exactly. Those were the two big players, geocentric versus heliocentric.
Right.
But there's actually a third model that often gets overlooked.
Okay.
And that's the geo-heliocentric model, which is where the Tychos model comes in.
Interesting.
Named after Tycho Brahe, a brilliant astronomer who lived before the invention of telescopes.
Oh, wow.
And get this, it's strikingly similar to a model proposed by an Indian astronomer named Pathani Samanta 2 centuries earlier.
Whoa! Great minds think alike, even across centuries and continents.
It's amazing, isn't it?
All right, I'm officially hooked, but how does this geo-heliocentric thing actually work? I mean,
Sure.
Earth is still at the center, but what makes the Tychos model so unique?
So the big twist with the Tychos model is that the Sun and Mars are a binary pair. Picture them locked in this gravitational waltz circling each other while they both orbit around the Earth.
Hold on, so instead of Mars orbiting the Sun, they're like a cosmic dance duo, just swirling around each other while they make their grand tour around Earth.
That's it! You got it!
Wow.
And that central idea, that Sun-Mars binary dance, has some pretty wild implications for how we understand the rest of the solar system.
All right, my brain is already doing the cosmic tango.
Good, good.
But why Mars? Jupiter's way bigger. Wouldn't it make a more, I don't know, logical dance partner for the Sun? I mean, size matters, right?
It usually does in most cosmic situations.
Right.
But this is where things get interesting. It's not just about size, it's about density.
Okay.
Think of it like this. Imagine you're trying to swing a bowling ball around versus a giant beach ball. The bowling ball, even though it's smaller, is way denser.
Yeah.
So it takes more effort to move in a circle, you know?
So it's like saying a small, super dense lead weight would be a better dance partner for the Sun than like a giant fluffy marshmallow.
Exactly. Perfect analogy. Mars is thought to be much denser than Jupiter, packing a lot of mass into a relatively small space.
Right.
That extra density means it has a stronger gravitational pull, making it a much more suitable partner for the Sun in this cosmic dance.
So it's a density dance-off, and Mars takes the crown.
Mars takes the cake.
Okay. This is already making me see our solar system in a whole new light. What are the other planets? Where do they fit in with this Sun-Mars tango going on?
Well, Venus and Mercury get a bit of a demotion in the Tychos model.
Okay.
Instead of being full-fledged planets orbiting the Sun, they become moons.
Whoa. Hold on.
Moons of the Sun, that is?
Venus and Mercury downgraded to mere moons. That's a bold move, even for a model that's already breaking all the rules. I mean, what's the evidence for this planetary reshuffling?
So it's all about their movements.
Okay.
Think about it. Both Venus and Mercury rotate incredibly slowly compared to other planets.
Right.
They're practically taking a cosmic nap.
Yeah.
Plus, they always show the same face to Earth, just like our own moon does.
So their slow-mo spin and the fact that they're always giving us the same side eye, that's enough to boot them from the Planet Club.
Well, it's compelling evidence.
And stick them in the moon category.
Especially when you consider that, no moon in our solar system has its own moon.
Right.
So they're already playing that sidekick role.
Okay.
And slow rotation, that's a classic moon move.
Okay.
It makes you wonder, have we been looking at our inner solar system all wrong this whole time?
I'm definitely starting to question everything I thought I knew about planetary real estate.
Good, question everything.
But what about the big names in astronomy like Johannes Kepler?
Right.
Didn't he champion the heliocentric model?
He did.
How does the Tychos model stack up against his work?
Okay, so Kepler was a staunch Copernican, that is true.
Yeah.
But here's the thing. He was famously obsessed with Mars.
Okay.
And he spent years trying to fit its movements into the heliocentric model,
Okay.
but he ran into a snag. Mars just didn't want to cooperate.
You're telling me the great Kepler, the guy who cracked the code of planetary motion, had trouble with a little planet like Mars?
He did. He really struggled with it.
That's some juicy astronomical gossip.
It is. It's a good story.
All right, so what was the problem?
Mars has these things called unequal retrograde periods. Now, before your eyes glaze over,
Yeah.
let me explain. Imagine you're on Earth watching Mars move against the background stars.
Okay.
Most of the time, it moves eastward.
Yeah.
But every now and then, it seems to loop backwards, moving westward for a bit.
Okay.
That's retrograde motion.
Okay, so Mars likes to back it up every now and then.
It does. It likes to zigzag a little bit.
I could dig it.
Right.
But what's unequal about these retrograde periods?
All right, so here's the thing. Mars aligns with a particular star 7 times at roughly 707-day intervals.
Okay.
But then on the 8th alignment, it only takes about 546 days to get back to the same spot.
So it's like Mars is playing a cosmic game of red light, green light. 7 slow steps forward and then a quick dash back.
That's a great way to put it.
Okay.
That doesn't sound very orderly for a planet that's supposed to be neatly orbiting the sun, right?
Right.
And this is where the Tychos model really shines.
Okay.
This quirky behavior of Mars makes perfect sense when you consider that Sun-Mars binary dance.
Okay.
Their combined motion around the Earth creates these variations in Mars's retrograde periods.
Right.
It's like watching a couple do a complicated dance routine.
Oh.
Their steps might seem strange individually, but together they create this beautiful pattern.
So the Tychos model is like the missing piece of the puzzle.
It could be.
The key to understanding why Mars has been acting up all this time.
It might just be.
I love how this is unfolding.
Yeah, it's pretty cool.
But let's zoom out for a second.
Okay.
If the Sun and Mars are this binary pair,
Mm-hmm.
is there anything else out there in the cosmos that might support this idea?
Well, look no further than Sirius, the brightest star in our sky.
Sirius, the dog star.
Yes,
Always a showstopper in the night sky.
it is a beauty.
But what does a distant binary star system
Yeah.
have to do with our own solar system model?
Get this. The proportions of Sirius A and B are remarkably similar to the proportions of our Sun and Mars.
Okay.
It's almost like looking into a cosmic mirror,
Right, yeah.
seeing our solar system reflected back at us, but on a much grander scale.
So are you suggesting that Sirius could be a glimpse into another solar system structure just like ours?
It's a tantalizing possibility.
That's mind-blowing.
It makes you wonder, are binary systems the norm in the universe?
Right.
And our Sun-Mars partnership is just another cosmic waltz in a vast starry ballroom.
Now we're talking.
Right.
A universe filled with binary systems, each with their own unique dance routine.
I love that image.
I can already hear that cosmic disco music.
It's a party out there.
All right, but before we get carried away with this intergalactic party,
Yeah.
let's talk about this 16 factor I keep hearing about in relation to the Tychos model.
Oh, yes.
What's the deal with that?
The 16 factor, it's one of the most mind-boggling aspects of the Tychos model.
Okay.
It suggests a level of interconnectedness in our solar system that's almost eerie.
Uh-huh.
For instance, did you know that the Earth's rotation is about 16 times faster than the Moon's rotation?
Wait, really?
It's that precise.
I've never noticed that before.
It's one of those hidden patterns that you wouldn't expect to find unless you were really looking for it.
Right.
And it goes beyond just the Earth and the Moon.
Okay.
The Sun's orbital speed around the Earth in the Tychos model is about 16 times faster than its own rotation speed.
Okay.
There are even more examples.
Wow.
And it leads to this incredible question. Could our solar system be an intricate, interconnected mechanism with the Moon acting like a central gear, influencing the motions of everything from the Sun to the outer planets?
Okay, hold on. I need to catch my breath here.
It's a lot to take in.
A cosmic gear system with the Moon as the master conductor.
It's a beautiful image, isn't it?
Makes you wonder if there's some kind of hidden intelligence behind all this.
It certainly does.
Wow.
And that's one of the reasons why the Tychos model continues to fascinate people even centuries after it was first proposed.
Okay.
It gives us a glimpse into a universe that's more connected, more harmonious,
Yeah.
maybe even more mysterious than we ever imagined.
This is officially the most mind-bending conversation I've ever had.
I'm glad to hear it.
But before my brain explodes,
Okay.
let's shift gears for a second.
Sure.
What about the precession of the equinoxes? Isn't that supposed to be caused by the Earth wobbling like a top?
Right. That's the classic explanation.
How does the Tychos model explain that?
So the Tychos model has a very different explanation for that phenomenon. It says that the Earth isn't wobbling at all. It's actually slowly orbiting a point in space called the PVP, which stands for Polaris Vega Polaris.
Hold up. So instead of wobbling like a spinning top, the Earth is doing a slow, graceful circle around this PVP point.
Exactly.
And that's what causes the stars to appear to shift over time.
Yes, it's like the Earth is tracing this giant invisible circle in the cosmos,
Yeah.
taking about 25,344 years to complete one loop.
Wow.
And as we move along that path, our view of the stars changes,
Yeah.
giving the illusion that they're slowly drifting across the sky.
So it's not the Earth wobbling, it's the Earth waltzing.
I love it, the Earth waltzing.
I'm starting to see a theme here with all this cosmic dancing.
It's a beautiful image.
It is.
And it really highlights how the Tychos model reframes some of our most fundamental assumptions about the universe.
Okay.
It challenges us to see the cosmos from a different perspective,
Yeah.
one where motion and interconnectedness are the key themes.
This is seriously making me question everything I learned in astronomy class. But wait, what about the moon?
Oh, the moon, yes.
There's all sorts of lunar mysteries, right? Can the Tychos model shed some light on those too?
It certainly can. In fact, it offers some really intriguing insights into the moon's movements and behavior.
Okay.
For instance, it explains the exoligmos cycle,
Yeah.
which is a recurring pattern of eclipses that spans roughly 54 years.
So we've got this exoligmos cycle, which is all about eclipses repeating in a certain pattern. How does the Tychos model connect the dots here?
So the exoligmos cycle is linked to the time it takes for the Earth-Moon system to cover a distance equal to the moon's orbital diameter as they move around the PVP.
Okay.
It's a subtle but predictable pattern that emerges naturally from the Tychos model's geometry.
So the Earth and Moon are basically doing a cosmic conga line around this PVP point,
I like that, a cosmic conga line.
and that creates the rhythm for the exoligmos cycle.
Exactly, and it shows how even seemingly complex astronomical phenomena can have surprisingly simple explanations. When you look at them through the lens of the Tychos model,
This is blowing my mind,
I
but
told you it was going to be a wild ride.
you did.
Yeah.
What about other lunar mysteries?
Yeah.
What about that wobble in the moon's orbit, the lunar evection?
Right.
Does the Tychos model explain that too?
Absolutely. So the lunar evection is actually not a true wobble at all.
Okay.
It's an apparent shift in the moon's position caused by our changing perspective as the Earth moves along its PVP orbit.
So it's another case of it's all about perspective.
Yeah,
Like those optical illusions where the image changes depending on how you look at it.
precisely.
Oh.
And here's another interesting point. The Tychos model shows that the moon isn't actually receding from Earth, as some theories suggest.
Okay.
That's another misconception that gets cleared up.
So no need to worry about the moon drifting away anytime soon?
Nope. The moon is here to stay.
That's a relief.
Yeah.
All right, but what about other celestial objects like asteroids and comets?
Right.
Where do they fit into this grand Tychonic scheme?
Okay, so the Tychos model reimagines the asteroid belt,
Okay.
not as the remnants of a destroyed planet,
Right.
but as a natural consequence of the Sun-Mars binary dance.
Okay.
Imagine these two massive bodies waltzing around each other,
Okay.
kicking up dust and debris as they go.
Okay.
That's your asteroid belt.
It makes sense. It's like a celestial demolition derby out there,
It is.
with the sun and Mars just stirring things up.
They're the troublemakers.
All right, but what about those spectacular meteor showers we get to enjoy here on Earth?
Yes.
How do they fit into this model?
So those dazzling streaks of light
Right.
are essentially cosmic breadcrumbs from the Sun and Mars's orbits.
Okay.
As they move around each other,
Yeah.
they leave a trail of debris in their wake.
Right.
And when the Earth passes through those debris fields, we get a meteor shower.
So those meteor showers are basically the aftermath of a cosmic fender bender between the sun and Mars.
It's one way to look at it.
Okay.
Yeah.
That's a pretty epic way to create a light show.
It is. It's a pretty spectacular show.
All right, but what about comets?
Comets, yes.
They seem to have their own more erratic paths through the solar system.
Right. They're the wild cards.
How does the Tychos model handle those?
Okay, so comets are definitely the wild cards of the solar system, but the Tychos model actually simplifies their story.
Okay.
It suggests that some of those seemingly erratic appearances, like Halley's Comet, might actually be misidentifications.
Wait, are you saying that astronomers might have mistaken different comets for Halley's Comet over the centuries?
It's possible.
It's like a cosmic case of mistaken identity.
It is, and When you factor in the Earth's slow movement around the PVP point,
Right.
it further complicates our attempts to track and predict the motions of these icy wanderers.
Yeah.
It's like trying to follow a firefly on a merry-go-round.
Right.
Not an easy feat.
Okay.
It makes you really appreciate the challenges faced by early astronomers, trying to map the heavens without all the fancy telescopes and computer simulations we have today.
Absolutely. They were true pioneers,
They were.
paving the way for our current understanding of the cosmos.
Absolutely.
And speaking of which, I think it's time for us to take a little break and let all this information sink in.
Yeah, take a breather.
We'll be back soon to delve deeper into the Tychos model
More to come.
and explore its mind-blowing implications.
Stay tuned.
But dear listeners, while we're taking a breather, we'd love to hear your thoughts.
Yes.
What stands out to you about the Tychos model so far?
Yeah, what are you thinking?
What questions are swirling around in your mind?
Share your insights with us, and we'll explore them further in our next episode.
All right, we'll be right back
See you soon.
after this break.
Absolutely.
Welcome back to our Tychos model odyssey. Last time, we left off with that mind-boggling idea that comet sightings throughout history might be riddled with these cosmic cases of mistaken identity.
Oh, yeah.
Really makes you wonder how much we still don't know about these icy wanderers.
It's a humbling thought, isn't it?
It is.
You know, our understanding of the universe is constantly evolving as we gather more data and refine our models.
Right.
And the Tychos model is a great example of how a shift in perspective can lead to some really surprising new insights.
Speaking of surprising insights, I'm curious about that 811,000-year megacycle we touched on earlier.
Oh, yeah.
That's a ridiculously long span of time.
It is.
What exactly happens during this cosmic marathon?
Okay, so the megacycle in the Tychos model refers to the time it takes for a remarkable celestial alignment to repeat itself.
Okay.
So after 811,000 years, the positions of the sun, moon, planets, even the asteroid arrows, return to almost the exact same configuration they had at the starting point.
So it's like a giant cosmic reset button?
Kind of, yeah.
Every 811,000 years, the whole solar system goes back to square one, celestially speaking.
Not exactly square one, but incredibly close.
Yeah.
Imagine it like a beautifully intricate cosmic clock ticking away over eons.
Right.
Every 811,000 years, the hands of this celestial timepiece align in a very specific way,
Okay.
marking a moment of extraordinary harmony and repetition.
Okay, so I'm picturing this vast cosmic clock with planets as its hands, just slowly sweeping through space.
It's a beautiful image.
It is, but 811,000 years is such an unfathomably long time.
It is hard to wrap your head around.
How can we even verify this megacycle?
Yeah.
I mean, do we have any evidence for it beyond theoretical calculations?
Well, remember that amazing Tychosium 3D simulator we mentioned earlier?
That's it.
It's not just a pretty picture.
Right.
It's a powerful tool that allows us to track the movements of celestial objects over incredibly long periods.
Okay.
And when we plug the Tychos model into the simulator and let it run, guess what happens?
Don't tell me after 811,000 simulated years, everything lines up perfectly, just like the model predicts.
We got it.
Wow.
It's not just theoretical speculation. It's backed up by these simulations that show how the Tychos model's intricate geometry leads to this remarkable repeating pattern.
And it's seriously impressive.
It is. It is.
But I have to ask,
Yeah.
what are the implications of this megacycle?
Right.
If the positions of the planets repeat after such a long time, does that mean events on Earth might repeat as well?
That's a great question.
Are we talking about some kind of cosmic destiny here?
Well, that's a question that has intrigued philosophers and scientists for centuries.
Right.
Is there a connection between these grand celestial cycles and events here on Earth?
Yeah.
It's a fascinating area for further exploration.
Okay.
And who knows what insights we might uncover as we continue to investigate these cosmic rhythms.
Okay, we're officially venturing into X-Files territory here.
It's a bit out there.
A cosmic clock, repeating celestial alignments, potential echoes of history written in the stars.
I love it.
This is blowing my mind, but before we get lost in a cosmic vortex here,
Okay.
let's bring it back down to Earth.
Well,
Literally. We've been talking about how the Earth moves in the Tychos model, slowly orbiting this PVP point. But what about its rotation?
right?
How does the Earth's spin on its axis fit into this model?
That's a great question.
Okay.
And it highlights a fundamental difference between the Tychos model and the traditional heliocentric model.
Okay.
So in the heliocentric model, the Earth's rotation is treated as almost incidental.
Right.
It spins on its axis
Yeah.
while also hurtling through space around the sun.
Right, like a spinning top that's also flying through the air.
Exactly, a spinning top on a roller coaster.
Okay.
But in the Tychos model, the Earth's rotation takes center stage.
Okay.
Remember that intriguing 16 factor we discussed earlier?
Yes.
Well, the Earth's rotation plays a crucial role in that intricate web of cosmic connections.
Okay, refresh my memory about the 16 factor.
Yeah.
It had something to do with the Earth's rotation being 16 times faster than the moon's rotation, right?
Yes, exactly.
Okay.
And the sun's orbital speed in the Tychos model
Yeah.
is about 16 times faster than its rotation speed.
Okay.
So this repeating pattern
Right.
suggests a level of harmony and interconnectedness that's truly remarkable.
Yeah.
And here's where it gets even more mind-blowing.
Okay.
In the Tychos model, the moon's motion is directly linked to the Earth's rotation.
Hold on. You're saying that the moon's movements are somehow controlled by the Earth's spin?
In a way, yes.
How does that even work? It sounds like cosmic puppetry.
It's more like a beautifully choreographed cosmic dance.
Okay.
Imagine a delicate balance between these two celestial bodies,
Right.
their movements intricately intertwined.
Right.
As the Earth spins, it subtly tugs on the moon,
Yeah.
influencing its orbital speed and trajectory.
So it's like a cosmic waltz with the Earth's rotation leading the dance and the moon gracefully following along.
Precisely.
Okay.
And this connection between the Earth's rotation and the moon's motion is one of the key elements that sets the Tychos model apart from the heliocentric model. It provides a completely different framework for understanding how these celestial objects interact and influence each other.
I'm starting to see how the Tychos model challenges some of our most deeply ingrained assumptions about the cosmos.
That's the fun part, isn't it?
It is.
Questioning what we think we know?
Yeah, it's like looking at a familiar painting from a completely different angle
Yeah,
and suddenly noticing all these details you never saw before.
exactly. You see things in a new light.
But if the moon's motion is so closely tied to the Earth's rotation,
Yeah.
what does that mean for familiar phenomena like, lunar phases
Mm-hmm.
and eclipses?
Good question.
Okay.
So the Tychos model actually explains lunar phases and eclipses in a very similar way to the heliocentric model.
Okay.
The key difference is the perspective.
Right.
Remember, in the Tychos model, the Earth is stationary at the center, while the sun and moon are revolving around it.
Right, so it's like watching the same celestial dance from a different seat in the theater. The dancers are the same, but their movements look different depending on where you're sitting.
It's all about perspective.
Right.
So in the Tychos model, the moon's phases are still caused by the changing angles of sunlight reflecting off its surface.
Okay.
And lunar eclipses still happen when the Earth passes between the sun and the moon, casting its shadow on the lunar surface.
Okay, so even though the overall stage is set up differently,
Right.
the basic choreography of lunar phases and eclipses remains the same.
It does.
It's comforting to know that some things stay consistent,
Right.
even when we're exploring radical new cosmic models.
Absolutely.
But what about other lunar mysteries?
Yeah.
We talked earlier about the exoligmos cycle
Mm-hmm.
and lunar evection.
Right.
Are there any other lunar puzzles that the Tychos model can shed light on?
You bet there are.
All right, hit me.
One long-standing puzzle in astronomy has been the moon's apsidal precession.
Apsidal precession.
It's the slow rotation of the moon's elliptical orbit over time.
Okay, hold on. I need a visual here. So we have this elliptical orbit,
Right.
which is like a stretched out circle.
Mm-hmm.
And you're saying it's slowly rotating, like a hula hoop, wobbling as it spins.
Perfect analogy.
Okay.
And the rate of this apsidal precession has
Right.
been a bit of a head-scratcher for astronomers.
Really?
It doesn't quite match up with the predictions of Newtonian gravity.
Interesting.
But guess what?
Yeah.
The Tychos model steps in and explains this discrepancy with a surprising amount of elegance.
You're telling me that the Tychos model can solve a problem that's been stumping physicists for centuries?
It appears so. I'm all ears.
So the Tychos model links the moon's apsidal precession to the Earth's slow orbit around the PDP point. As the Earth gracefully glides along its path,
Yeah.
it gently tugs on the moon's orbit, causing it to slowly rotate over time.
So it's another example of the Earth's motion influencing the moon's behavior.
Exactly. That cosmic connection strikes again.
And the rate of this precession, as predicted by the Tychos model, aligns perfectly with the observed data.
Wow.
It's a beautiful illustration of how this model can account for some of the subtle details of celestial mechanics that other models really struggle to explain.
Okay, my brain is doing backflips trying to keep up with all these interconnected motions and influences.
I know it's a lot.
But I have to ask, what about the bigger picture?
Okay.
We've been focusing on the Earth and the Moon,
Mm-hmm.
but what about the rest of the solar system?
Right.
How does the Tychos model handle the movements of the other planets, especially with this Sun-Mars duo doing their thing in the center?
Well, remember, it's all about perspective.
Right.
In the Tychos model, the other planets are still orbiting the sun, but they're doing so while the Sun-Mars pair is simultaneously waltzing around the Earth.
So it's like a cosmic mobile,
Oh, I like that.
with the Sun and Mars as the central piece, and the other planets dangling around them.
Yeah.
But with a much more complex and beautiful choreography than your average mobile.
A very intricate and dynamic mobile indeed.
Right.
And this setup leads to some fascinating orbital patterns.
Okay.
Remember how we talked about the unequal retrograde periods of Mars?
Yes.
Well, the Tychos model predicts similar variations in the movements of other planets as well.
So Mars isn't the only one with fancy footwork.
Nope, they're all getting in on the cosmic dance.
Okay.
They're all influenced by the combined motions of the Sun, Mars, and the Earth.
Okay.
And these complex interactions create some truly mesmerizing orbital patterns that can be observed and mapped using the Tychosium simulator.
So we've got a solar system that's less like a predictable clockwork and more like a grand interconnected ballet,
I love that.
with every celestial body playing its part in this intricate cosmic performance.
It's a beautiful image.
It is, but I have to admit my brain is starting to feel a little overloaded with all these cosmic revelations.
I understand it's a lot to take in.
It is,
Mm.
especially when it challenges some of our most deeply held assumptions about the universe.
Right.
But that's what makes it so exciting.
It is. It pushes us to expand our understanding and embrace new ways of seeing the cosmos.
You've definitely sparked my curiosity.
Good.
I'm ready to keep diving deeper.
Right.
What other mind-blowing insights does the Tychos model have in store for us?
Well, one of the most compelling aspects of the Tychos model is its interpretation of stellar parallax.
Okay.
You probably remember stellar parallax as the apparent shift in the position of a star when viewed from different locations in Earth's orbit.
Right, it's that looking at your thumb with one eye closed and then switching eyes trick, but on a cosmic scale.
Exactly. That's a great way to visualize it.
And it's been one of the key pieces of evidence supporting the heliocentric model, right?
It has been, yes, but the Tychos model offers a completely different explanation for stellar parallax.
Okay.
One that doesn't rely on the Earth orbiting the sun.
Intriguing. I'm all ears.
All right, let's hear how the Tychos model tackles stellar parallax without needing the Earth to go on a joyride around the sun.
Okay, we're back for the grand finale of our Tychos model deep dive. And I'm ready for more cosmic curveballs.
All right, bring it on.
Last time, we left off with this really tantalizing cliffhanger.
Mm-hmm.
How does the Tychos model explain stellar parallax if the Earth isn't orbiting the sun?
Right.
It sounds like we're about to rewrite the astronomy textbooks.
It definitely challenges the conventional view, and that's what makes it so fascinating.
All right.
So remember, in the Tychos model, the Earth isn't just sitting still at the center of the universe.
Right.
It's slowly orbiting that distant PVP point,
Right.
creating this vast, subtle dance across the cosmos.
Right, the grand cosmic waltz we keep coming back to.
Exactly.
But how does that waltzing motion create the illusion of stellar parallax?
Okay, so imagine you're walking around a large circular fountain, watching a friend standing in the center.
Okay.
As you move, your friend's position relative to the background scenery appears to shift,
Right.
even though they haven't moved an inch. That's essentially what's happening with stellar parallax in the Tychos model.
Okay, so as the Earth moves along its PVP orbit,
Mm-hmm.
our perspective on the stars changes,
Yeah.
creating the illusion that they're shifting position,
Yes.
even though they're not actually moving.
It's all about our cosmic point of view.
Right, so it's an apparent shift, not an actual one.
Exactly. And the amount of this apparent shift, as predicted by the Tychos model, lines up remarkably well with the actual data on stellar parallax that astronomers have observed.
So the Tychos model takes this phenomenon
Mm-hmm.
that's been used as a cornerstone of the heliocentric model
Right.
and offers a completely different yet equally valid explanation.
That's right.
That's pretty ingenious.
It's a great example of how a different perspective can unlock new ways of understanding familiar phenomena.
Yeah.
And what's even more intriguing is that the Tychos model's explanation of stellar parallax leads to a truly mind-blowing implication.
Okay, what's that?
The stars might actually be much closer than we currently think.
Hold on, are you saying that the stars, those distant suns scattered across the vastness of space, might not be light years away after all?
It's a possibility.
That changes everything.
It does.
Okay.
See, in the heliocentric model, the distance to the stars is calculated based on the assumption that the Earth is zipping around the sun at a certain speed.
Right.
But in the Tychos model, the Earth's orbital speed around the PVP is much slower.
Right.
And that changes the whole equation.
So a slower earthly pace means a smaller cosmic neighborhood.
Exactly.
It's like saying if you walk to the grocery store instead of driving,
Right.
the source suddenly seems much closer.
Exactly. Perfect analogy.
Okay. And according to the Tychos model, how much closer are we talking?
Well, according to the Tychos model, the stars might be thousands of times closer than we currently estimate.
Wow, that shrinks the universe down quite a bit.
It does.
It's like realizing that your neighborhood is much cozier than you thought.
Right.
Suddenly everything feels more connected. Yeah, more intimate. But if the stars are actually that much closer, what does that mean for our understanding of the universe as a whole?
It opens up a universe of possibilities.
I like that.
It suggests a cosmos that's more compact, more interconnected,
Okay.
perhaps even more harmonious than we ever imagined.
Right.
It challenges us to rethink our place in the grand scheme of things.
Yeah.
And consider that we might be more intimately woven into the fabric of the universe than we previously thought.
It's a beautiful and humbling thought.
It is.
Realizing that we might be more connected to those twinkling stars than we ever dared to dream.
Absolutely.
Okay.
It's really quite awe-inspiring when you think about it.
It is, but before we get lost in cosmic contemplation,
Right.
there's another intriguing piece of the Tychos model that I'm eager to explore.
Sure. What's that?
The analemma.
Ah, yes, the analemma.
I remember seeing that figure-8 shape on globes and sundials, but I never really understood what it represented.
So the analemma is a visual representation of the sun's position in the sky at the same time of day throughout the year.
Okay.
And you guessed it, the Tychos model offers a unique perspective on how this fascinating pattern comes to be.
I knew there had to be a Tychonic twist to it.
There always is.
Okay.
So how does this figure-8 shape fit into the Earth's cosmic waltz around the PVP point?
Right, exactly.
Think about it this way. As the Earth moves along its PVP orbit,
Yeah.
our perspective on the sun changes.
Okay.
Just like with stellar parallax.
Yeah,
It's
yeah.
like being on a carousel and watching someone standing still in the center.
Okay.
Their position appears to shift back and forth as you go around.
So our moving viewpoint creates the illusion of the sun tracing out this figure-8 pattern across the sky.
Exactly. It's all about relative motion
Okay.
and how our changing perspective creates these apparent movements in the heavens.
Right.
And the Tychos model predicts the shape and orientation of the analemma with incredible accuracy.
It's another example of how this model elegantly accounts for observable phenomena
Yes.
in a way that challenges the conventional view.
It does make you think.
It does, it does. But what about those bigger, more existential questions?
Right.
Does the Tychos model have anything to say about, the origin and structure of the universe itself? Or is it mainly focused on our little corner of the cosmos?
Well, the Tychos model doesn't necessarily contradict the idea of a vast, expanding universe.
Okay.
But it does suggest that our place within that universe might be much more central and significant than we currently believe.
Central. But doesn't that sound a bit, geocentric?
I see where you're going with that.
I mean, haven't we moved beyond the idea of Earth being the center of everything?
It's not about returning to a purely geocentric view,
Okay.
but recognizing that our perspective from Earth, as described by the Tychos model,
Right.
might offer a unique and privileged window into the structure of the cosmos.
So it's not about putting Earth back on a pedestal.
No, not at all.
Yeah. But understanding that our vantage point might be more special than we realize.
Yeah, more significant.
It's kind of like having front row seats to the cosmic show.
Exactly.
Okay.
And the Tychos model provides some intriguing hints about why our perspective might be so unique.
Okay, like what?
Well, remember that incredible 811,000-year megacycle where all the planets align in a specific way?
Right. The grand cosmic clock ticking away across millennia.
Yes. Well, there's another remarkable alignment that occurs during that cycle, and it involves our old friend, the Sirius star system.
Sirius, the celestial celebrity.
That's the one.
What does it have to do with this cosmic alignment?
So according to the Tychos model, our solar system and the Sirius system are engaged in this slow, graceful dance around each other.
Hold on. So our whole solar system is waltzing with Sirius.
That's the idea.
This is getting more epic by the minute.
It is. It really is.
But why is this particular alignment so significant?
Well, it suggests a level of interconnectedness that's truly mind-boggling. Our solar system isn't just adrift in a random sea of stars. It's
Right.
part of a larger cosmic structure, a celestial ballet with Sirius as our dance partner.
Right.
And who knows what kind of influences or connections might be at play across those vast distances.
Okay, my head is officially spinning.
It happens.
We've got a cosmic dance between our solar system and Sirius, repeating every 811,000 years.
Right.
Does this grand cosmic ballet have any impact on us here on Earth? Are we talking about astrological influences or something even more profound?
That's a question that researchers are still exploring.
Okay.
Some believe that this Sirius cycle might be connected to certain cyclical events on Earth, like ice ages or periods of increased volcanic activity.
Whoa, are you saying that our cosmic dance with Sirius could be influencing the very rhythms of our planet?
It's a possibility, and it's just one of the many fascinating avenues of exploration that the Tychos model opens up.
Right.
It encourages us to look beyond our immediate surroundings and consider the interconnectedness of the universe in ways we never imagined before.
This has been an incredible journey.
It has.
We've explored binary dances, lunar mysteries, cosmic gears,
Such a wild ride.
celestial ballets.
I know, right?
And the possibility of a universe that's both smaller and more interconnected than we ever dreamed.
Exactly.
I feel like I've just taken a crash course in cosmic consciousness.
It's been my pleasure exploring these ideas with you.
Right back at you.
The Tychos model, with its unique perspective and elegant explanations, it really challenges us to rethink our place in the cosmos.
It certainly does, and to our listeners out there, as you gaze up at the night sky, remember that what you see is just a small glimpse into this vast and intricate tapestry of celestial wonders.
That's a beautiful thought.
And maybe, just maybe, the Tychos model will inspire you to see the universe in a whole new light.
Until our next deep dive, keep those minds curious and those imaginations soaring.
Absolutely. See you next time.